We are whizzing along in the textbook and we are on starting chapter 8, quadrilaterals and polygons. So in 8.1 we are going to find angle measures in polygons. If the measure of two angles of a triangle are 19 and 80, find the measure of the third angle. Well, we always start at 180, subtract 80, subtract 19. I obviously messed that up. 100, 1,000, having all kinds of issues here. 100 minus 19 is 81 degrees. And solve this problem. You're going to multiply 180 by both, distributing it. So 180x minus 2 times 180 is 360 equals 1,980. You're going to add 360 to both sides. This should be a nice, easy review for you. 1,980 plus 360 is 2,340. So 180x equals 2,340 divided by 180, and your answer is, I need to grab it, not write on it, 13. Pay attention to that formula. You're going to be seeing it a lot today. And the last one, find the value of x. These are two opposite rays and another line. These make a linear pair. They add up to 180. So 180 minus 54 is 126. Two vertices that are endpoints of the same side are called consecutive vertices. So like B and C are consecutive vertices. A diagonal of a polygon is a segment that joins two non-consecutive vertices. So in polygon A, B, C, D, E, there's two diagonals from B, segment BD, and segment BE. As you can see, the diagonals from one vertex form triangles. We did an activity on the previous page where we found the sum of the interior angle measures of a polygon. So this gives us the polygon interior angle theorem. The sum of the measure of the interior angles of a convex n-gon is n minus 2 in parentheses times 180. So basically, however many sides your polygon has, this one is 6 sides, you'd put that in for n. So 6 minus 2 would be 4 times 180 will give you the sum of the interior angles. The corollary to this is that the sum of the measurements of the interior angles of a quadrilateral is 360. We'll use that a lot. You just know that it's 360. Triangle, you just know, is 180. But if you look at a triangle, it actually does follow this same formula. There are 3 sides in a triangle. 3 minus 2 is 1. And 1 times 180 is 180. So we're going to use this. Find the sum of the measures of an interior angles of a convex octagon. An octagon has 8 sides. So n minus 2, which is 8 minus 2 is 6. And 6 times 180 is 1,080. We can also find the number of sides of a polygon by basically working this backwards. So if I tell you that the measure of the interior angles of a convex polygon is 900 degrees, classify the polygon by the number of sides. So now we're finding n. n minus 2 times 180 is 900. We divide both sides by 180. We get n minus 2 is equal to 5. Add 2 to both sides, and n equals 7. The polygon has 7 sides. It is a heptagon. The point shown is in the shape of a regular 11 gon. Find the sum of the measures of the interior angles. So you might remember, hopefully you remember, the formula is n minus 2 times 180 equals the total. 11 minus 2 is 9 times 180 is 1,620. Yes, you don't need to write out the formula every time. In the next one, the sum of the measures. If you read the problem, they now want us to find the number of sides. You may not need to write out the formula every time. You use a calculator. 1,440 divided by 180 is 8. If n minus 2 equals 8, I add 2 to both sides, and I get n equals 10. 10-sided shape is a decagon. Polygon is a quadrilateral. We already had a corollary that told us that these are all going to add up to 360. So 108 plus 121 plus 59 is 288. 360 minus 288 is 72. So use the diagram at the right to find the measure of S and T. Well, this is a 5-sided shape. 5 minus 2 is 3. And 3 times 180 is 540. So if I start at 540 and I subtract 93 and I subtract 156 and I subtract 85, I get that the 2 remaining angles have to add up to 106. Since there's congruent marks there, they're obviously equal, and half of 206 is 103. So S and T are both 103 degrees. The measure of the 3 of the interior angles of a quadrilateral is 89, 110, and 46. Find the 4th. So I'm going to start at 360. I'm going to subtract 89. I'm going to subtract 110. And I'm going to subtract 46. And that equals 150. So the last interior angle is going to be 150. Now we're going to talk about exterior angles. Unlike the sum of the interior angles, angle measures of a convex polygon, the sum of the exterior angle measures does not depend upon the number of the sides of the polygon. The diagram below shows that the sum of the measures of the exterior angles, one at each vertex of a pentagon, is 360 degrees. In general, the sum is 360 degrees for any convex polygon. So Theorem 8.2, polygon exterior angles theorem, says that the sum of the measures of exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So with that, we're going to look at a standardized test practice question. Which is the value of x in the diagram shown? Okay, this is a 4-sided shape. So x plus 2x plus 89 plus 67 equals 360. Combining like terms, 3x plus 156, because we added the 89 and the 67, equals 360. So they've combined some steps here, but basically you had 360. You subtracted 156 from both sides. You got 204. You divided by 3, and you got 68, which was B. Trying a guided practice for this question. A convex polygon has exterior angles with measures of 34, 49, 58, 67, and 75. What is the measure of the exterior angle at the 6th vertex? So I'm just going to start at 360. I'm going to subtract 34. I'm going to subtract 49. I'm going to subtract 58. I'm going to subtract 67. And I'm going to subtract 75. And I get 77. The 6th exterior angle is 77 degrees. The trampoline is shaped like a rectangular dodecagon. Find the measure of each interior angle and measure of each exterior angle. So a dodecagon, if you didn't know, you could count these up, is 12. 12 minus 2 is 10. 10 times 180 is 1800. And since the exterior angles all add up to 360, okay, we first wanted, I messed up, the measure of each interior angle. The total is 1800. Since they're regular, dodecagon, we divide by the number of angles, that's 150. The measure of each interior angle is 150. For the exterior angles, since they're going to add up to 360, 360 divided by 12 is 30. You also will notice that 30 and 150 form a linear pair. That makes sense because they're a linear pair, so they're going to add up, have a sum of 180 degrees. Guided practice for this question: an interior angle and an adjacent exterior angle of a polygon form a linear pair. How can you use this fact as another method to find the exterior angle measures in example 5? Well, whoops, think I went ahead not realizing that this was going to talk about it. Since the interior angle is 150 degrees, the exterior angle would be 30 because they form a linear pair. If you want to see all of that, you didn't like the way I explained it, there it is. And the daily homework is find the sum of the measure of the interior angles of a convex 24gon. So 24 sides minus 2 is 22 times, oops, I hit something wrong there, 22 times 180 is 3,960. Next problem, the sum of the measures of the interior angles of a convex polygon is 5,040. Classify the polygon by the number of sides. So once again, n minus 2 times 180 equals 5,040. So if I take 5,040, I divide by 180, that means n minus 2 is 28, add 2, and I'm going to get 30. So it's a 30gon. Next homework problem, find the value of x. So these all, I'm going to combine like terms here. We have 3x plus x plus 72 plus 46 plus 110. So 3x plus x is 4x, 72 plus 46 plus 110 is 228. This all is going to equal 360. So 360 minus 228 is 132. So if 4x equals 132, 132 divided by 4 is 33. So x would be 33. And find the measures of an interior angle and an exterior angle of a regular 36agon. So we're going to find the total sum of all of the interior angles first. 36 minus 2 is 34 times 180. So there's 6,120 degrees total. But there's 36 angles, so I have to divide by 36, and that's 170. Now, since they're going to form the interior angle and the exterior angle is going to form a linear pair, they have to add up to 180. So 170 is the interior, and 10 is the exterior. And here you go. You can go through these pages to look at and do your homework for this lesson.